I'm Rob May. I'm the CEO of Neurometric.
And I'm Cooper, COO here at Neurometric. We're co-founders, and this is Inference Time Tactics, a podcast for builders, researchers, and engineers who want to understand what's happening in this next era of AI.
The next performance gains are not just about bigger models or more training data, but about how we orchestrate inference at runtime. And that's why we're building Neurometric.
So let's dive in. In this episode, we're going to talk about GPT-5. It launched to a mixed reception, delivering incremental but solid improvements against benchmarks, but it doesn't feel transformative, more refinement than revolution. And for me, the real story is the router that decides when a request should be fast and when it should think longer. And that looks like a strategic bet on inference control more than a single capability leap. In fact, this drew significant pushback from users. OpenAI even removed older models at launch, but restored GPT-4 and the model picker due to feedback. And so given all this controversy, what problem do you think the router really solves? And what was OpenAI trying to achieve with this release?
What they're trying to achieve with the release is they're in a race with obviously Anthropic and Google and a few other smaller players, but those are the two biggest who are sort of constantly leapfrogging each other. So a few months ago, Gemini had the best model, and then Grok, and then Claude on coding, and then now GPT-5 for certain things. So they're trying to stay relevant and stay in the game because the switching costs for users are very, very low. So this is a tough game to play and stay ahead. But let's take a step back and talk about the strategic decisions, what it means for the layers of the technology stack to have this router built into GPT-5. Because the thing that's interesting is the market has been in this place of like performance capabilities, right? What can these models do? What can you build with them? What are the capabilities? And now that those are getting built out, we're starting to see people actually architect systems around it. I think there's been this perception from just maybe like your intelligent layman that people have been architecting these AI systems for a while now, but they really haven't. So much of even the usage that you see and everything, it's like testing, it's projects, it's pilots. What happens now is that as people start to think about rolling things out, they think about, do they want just the API calls that a foundation model lab will allow you, and I'm sure with the right amount of money, if you're a big enough partner, you can get better deals. But if you talk to a lot of smaller mid-stage technology growth companies like I do, they have a lot of problems. I mean, I talked to a company the other day that it's like, which model do you use? They're like, all of them, because we pass queries to, whichever model. And then if we hit a limit or we hit a problem or whatever, we jump to the next model. They also self-host some. And so people are starting to architect systems like that, where it's not just about the capabilities of the model. It's about the cost structure. It's about the latency. It's about the accuracy. There are some use cases where you need a 95% accurate answer, and there's some where you just need a ballpark answer or whatever. And then, if you're generating marketing content, you just need something that sounds reasonable, right? I don't even know how you evaluate how good that is by some metrics. A use case like search requires a lot of very low latency, right? You want to get something fast, but if you're asking it to do a task that you expect to take a couple of minutes, well, sending that to a cheaper model and adding another 25 seconds to it probably doesn't move the needle, right, on the user experience. So that's okay. And as these models, I think the surprising thing that people have learned is there's been this view in the AI world that it's just going to be one giant model and somebody's going to win and it's going to take off and do everything. And I think what we're starting to see is that might not be the nature of intelligence, that there may not ever be one model to rule them all. And even if there is, you can almost always run a smaller, faster, cheaper model unless you need a model that knows everything. If you can just direct your queries to, this is the model that knows about writing English language. This is the model that knows about solving math problems. This is the model that, knows facts from Wikipedia or whatever it may be. You can save a lot of time and money. And so I always think about AI things. Here's my mental model. I always think about AI things in terms of how do humans do it? So think about it this way. Let's say you had the smartest human that you have ever met, and they're also the most educated, and they've read all the books. Would you have them do everything, even if you could replicate them? Or would you just be like, I can get somebody for 10% of the price to go do this like entry-level admin task. That's what I should do. Models are going to break out the same way. And so what's happening is, for the first time, we're starting to engineer these systems. And by engineering these systems, rather than just testing their capabilities, we're starting to realize that every agentic system that's out there in a few years is going to use multiple models, probably from multiple providers, for multiple things, some of which they've trained for themselves, some that are small language models, some large language models, some old, some new, some open source, whatever. That's going to be what your system looks like. And so your job as the system architect is to figure out what's the balance between supporting the minimum number of models that you need to maximize your accuracy, cost, latency, whatever it is that you're trying to do. And so this routing problem, as a result of this, is going to grow quite a bit, right? And it's going to take on a lot of different forms. And I think there's going to be multiple successful router companies, some built into these sort of full stack model providers like this, and others that are independent.
And building it into the user interface for OpenAI has a real tangible impact on their cost structure. Like, I know Sam Altman tweeted that just saying please and thank you to chat was costing them tens of millions of dollars per month. And so, or not per month, but tens of millions of dollars. And so maybe this is helping address that problem as well. Something I thought was interesting also is this GPT-5 controversy really brought inference time compute into the mainstream. Like, I'm reading about it in Financial Times and Reuters, and this was just a academic emerging field in computer science just a few months ago.
Yeah, I mean, nobody even really talked about it until like last year, September, October. I mean, it's been less than a year, right? I think it's roughly a year since OpenAI's first reasoning model launched, which sort of, if you look prior to that date at the research that's out there, you can only find a few dozen papers even on inference time compute. And most of it wasn't on specific inference tactics, but was about doing things in inference time versus training time. So yeah, I mean, they really opened up an interesting can of worms in a very short period of time. And so yeah, all the academic people and the foundation model labs have sort of been talking about it for the last, call it 9 months, maybe as long as 12 months. And now it's for the last few weeks, the media zeitgeist of the average person is finally starting to know what it is. I mean, it's funny, right? Because when we were raising our round of funding, I would get on the phone with VCs and I would say like, and this was all in, call it May, June timeframe of 2025, if you're watching this podcast many years in the future. And I would ask, like, do you know the term test time compute or inference time compute? And most people would either say no, or they would go, I've heard of it, but I really don't know what it means. But we didn't talk to any. It's probably one of the hottest spaces that you could invest in and start thinking about for AI. And almost no investors, unless they were deeply, deeply steeped in AI, really even knew what that was. So it's nice. It's nice seeing it come to the forefront, because I am a big believer. I mean, I said this to you a lot of times, but I think like the space of inference time compute possibilities is vastly underexplored. And so I think you're going to see a lot of cool stuff come over the next few years in this space. And I actually think you're going to see inference time and training time kind of like merge, in terms of the distinction between the two is going to be smaller.
Absolutely. So let's zoom out to agents. If we define an agent as a persistent AI service with memory and a go loop, take mobile and web users, add a couple of agents per person, add work agents at the edge, device or environment agents, and you're looking at billions of AI agents by 2030. That's massive. And if agents are doing the calling, not people, programmable inference stops being optional. And so what must builders think about as we enter that era?
Let me tell you what it reminds me of, right? So typically, technology decisions that are presented as strategic are only mildly strategic, right? They're really about a trade-off between sort of like efficiency of running something versus the cost to build it. How efficiently is it to maintain it? Different things like that throughout the history of technology when you're building web applications or whatever. Do you want more control? Does your app benefit from, going deeper down the stack, building on a bare metal server or whatever versus building something serverless and all that. How much do we want to be relying on third-party providers? This adds a whole new dimension to it because there's a lot of uncertainty and things are changing really quickly. And you have to make bets in uncertain technology times. It sort of reminds me of the early days of the NoSQL movement when you had people who went, number one, you don't need a NoSQL database. You can figure out how to do all this in Postgres or MySQL or whatever was out at the time. And then there were people who went, well, we just have to wait and see because I don't know if Riak or Mongo or Cassandra or what was going to be popular. There were a whole bunch more at that time, right? And it was really hard to figure out which ones were going to win and why and for what use cases. So they were difficult technical bets to make. And now this is like a strategic problem like that on steroids because you're trying to figure out, where is the world going? How do I make sure I don't rely on somebody who's not going to be around in the future or take a direction that I don't want to go? You have to think about how much control you want versus how much, you could do a bunch of open source models. And if you're doing something simple, they're really easy to set up. If you're doing something complicated, it's going to be a lot of work to get them to the same level as an Anthropic or OpenAI or Gemini model. But at the same time, sometimes learning some of that is good. And maybe you do want to control it, right? So I think you have a couple of vectors, and this control vector is really unique because I think companies all have value chains. It's the steps of work that they perform to make a thing that they make. And for digital companies and knowledge-driven companies, their value chain is a lot of IP and a lot of intellectually related workflow steps. Those steps can now be done by machines. So if your value chain, you don't want to turn your core value chain over to a third party, right? That's bad business. So if the inference time or if the orchestration that you build or can build or even configure using what somebody else has built is unique to your business, then maybe you've got some small language models trained, you've got some verifier models trained on your own data, whatever it may be. You don't want to turn that over to other people, right? I mean, we've seen that even if OpenAI or Anthropic has clauses in their enterprise contracts that say we won't train on your data or whatever, they can still see your prompts and they know what's getting traction. This is why Anthropic came out with Claude Code, because they saw that their two biggest customers were coding customers and they were like, oh, we should get into this business. And so I think if you use these long term and you have something that's a relatively digital value chain, you're going to see competition from the model lab provider. So particularly if I was big banks or insurance companies or finance companies, and I was, building agents for personal wealth management or banking or, stock information, whatever, I would not personally use these models, but those are things you have to think about, right? I don't have a good framework for this yet. This might be a good future show to come up with a framework for how people should think about this strategically, but I think you have to balance privacy, control, reliance on third-party vendors with your core technical issues of accuracy of what the models provide, the cost structure of that, latency, and then just the complexity of, managing 8 or 9 models versus 2 or 3 models and all that kind of stuff. So it's going to be tough, but people that figure it out are going to be pretty far ahead.
Yeah. So a few months ago, we were betting that inference was more than just a fringe computer science field. And now we're making the bet that inference optimization is going to be a major market and a source of competitive advantage for enterprises and builders. And so we have a release coming in the next few weeks. Maybe we can't share too much, but is there anything we want to talk about?
People want to know a little bit about what's coming. It's we hope to launch a leaderboard on Inference Time Tactics. And so if you think about the way these different inference algorithms are put together and the combinations, they kind of have a bunch of core parts. They have a sampling part, a search part, they have a processor outcome sort of, reward model. And there's a few dozen pieces that you can pull together. And each of those dozen pieces has several different options as well. So combinatorially, there's a lot of things you can do. And then obviously when you pull something in like a best of n algorithm, like n could take any number in the world. So, it's usually doesn't take too high a number, but that's possible. And so we've built a system internally that can iterate through those and sort of tell you on different models versus different benchmarks, which inference time compute recipes maybe are the most useful to you, because the interesting thing about applying this stuff at inference time is sometimes it moves the needle quite a bit and sometimes it doesn't. It depends on the model that you're using. It depends on the benchmark. It depends on the specific tactic. So hopefully we will have a leaderboard out soon that shows you some of the results that we've had and seen internally. It's going to be focused more on work-related data than academic benchmarks. You'll see, I think the first stuff that we publish will probably be around Sierra Marina, because that's a very good work-driven data set. But we hope to put a lot more out over this time and be able to show really for the market and the people building this to understand what models and tactics they should be, combinations they should be looking at to get to where they need to go. So hopefully we can help them make those strategic decisions that we were just talking about, 5 minutes ago.
Absolutely. And this isn't just driving strategy in the software world. This is also impacting how we think about chips, how we think about data centers. So building on that demand for inference, let's talk capacity. Analysts now expect most data center compute and power to go to inference rather than training, with estimates at 75% or more over a model's useful life. And we're seeing that shape build outs. I was reading just the other day, training makes AI and inference uses AI, and the usage of AI has gone through the roof. And so the opportunity right now to make a chip that is vastly better for inference than for training is larger than it has been previously. So that was the CEO of Cerebras. So hundreds of billions of dollars are flowing in that direction. And even OpenAI announced Stargate Norway. And it's a massive project. And it seems different than a traditional strategic build out. Like this is outside of the normal places people are building data centers. And so with inference and routing at scale, is that changing how we expect to see hardware and data center build out take shape?
Two things that you can take away from it. Number one, I do think some of the, what I would call AI accelerator challengers will have a play here. For those of you who don't know, so an AI accelerator is a chip that is purpose designed to accelerate AI types of computations. Some of these challengers are Cerebras is probably the most famous. Grok with a Q has what they call an LPU, which is a specific type of chip that runs an LLM in a deterministic way, which is kind of cool. Samba Nova is one, and then there are a lot more, specifically some for the edge that are either analog or neuromorphic or have these unique different chip architectures. And most of these, some of these can train really well, but training is so well ingrained with NVIDIA and inference less so, that I think these chips are going to have more success on the inference side. So I think that's one thing that you'll see. Perplexity a couple of months ago announced that their AI search was going to be run by Cerebras. And I think that makes a lot of sense. Like if you have high throughput, high latency, low latency requirements for high computational AI processes, I would probably do something like Cerebras, right? And then if you're cost conscious, I would use something else. And then, if you're just sort of, batching things and just need some good solid AI, and it can take a little bit longer, like I would stick with GPUs and things that people know well. And also the GPUs are getting better all the time anyways, right? So that'll happen. On the data center side, it's so different. Like the mental model that I tried to use in the beginning, which I think was wrong, was how the web spun out and was built out. And you had these companies like Cloudflare and Akamai who, would cache web pages to the edge, because we know, particularly for shopping, but also for news and everything else, like if the page loads slowly, you just lose interest.
I need it right now.
Yeah, exactly. And it's not that way with AI. It'll be interesting to see if that changes, but we know that if we ask a person to write an essay that's 1,000 words, it's going to take them a few hours. So we don't expect AI to generate it in 2 seconds. AI can generate that in seconds to minutes, right? Probably 90 seconds or less for most of the main models, but we're willing to give it a little bit of time. So I think there will be this. So again, the strategic decisions around the data centers and how they tie to inference usage will be different than they were for the Web 1.0, because the caching won't matter just as much. To the point you made earlier, maybe saying things like please and thank you to the model will be cached somewhere so that you can just hit that. And you don't have to run through the model every time. And running the model one time is computationally expensive and expensive from a power consumption basis. And, you are going to want something to be at least reasonably geolocated to somebody. I mean, you don't want to go halfway around the world just to access data, ever, because that's just going to slow down. But I don't know that people are going to jam things near population centers like they did before to minimize that level of latency. I think you'll be able to tolerate, tens of milliseconds extra in a lot of use cases. And so I think a lot of what's going to drive this data center location is, I think you'll see data centers optimized for certain types of batch processing. So it's not as fast, but it's, this is a place that has, great cooling capacity and, good access to power and
renewable energy,
stuff like that. All these things that are, built next to a river or a windmill farm, or can take advantage of solar, or, a grid that's not already overtaxed. So I think that the changes in inference compute over the next 5 or 6 years are going to lead to maybe some bifurcation in the data infrastructure market that we haven't seen before, where people are going to build whole data centers that are for batch inference that doesn't need, low latency, and then certain tasks that are run in low latency data centers and everything else. And those might have a mix of compute that's kind of different. So, I expect to see a lot of changes because of this. Because again, when you look at previous tech waves like web or cloud or mobile, the usage constraints were much more similar. When you're looking at AI fundamentally replacing thinking or intelligence, that's a very broad category that means a lot of different things across a lot of different tasks. And the way that work has been broken down into, it might be a good mental model, right? If you follow Cal Newport and you've heard the term deep work, there are things you can do that just, and off the top of your head, you're just helping people with quickly. And then there are things where you're like, I need to sit for 2 hours and get into this because I'm researching things or I'm writing something and I need to synthesize it all. And so I think, I think you might start to see inference data centers sort of data infrastructure break out with a sort of similar way, system 1 and system 2 thinking maybe.
Absolutely. I was reading a paper the other day around sleep time compute. I'll send it to you. It's interesting. Okay. But this is encouraging. I mean, when we think about scale, OpenAI's heading towards 100,000 GPUs by the end of the year, or
I think they said 100 million they want to have, right? Or
that's what they're
like
going to scale to, right?
Yeah.
And so they're already approaching a small city in terms of energy use, and that's going to scale to the size of a country. And so we're going to have to think critically about optimizing where we put data centers. And and
I do think one of the things that's going to change is that, this isn't sustainable. And we know, I had this discussion a couple of days ago with a former MIT AI professor who's now on the entrepreneurial side about the math that drives these models and builds them is not efficient. And we know there's better ways to do it. We just don't know what they are. But we know the brain doesn't use backpropagation, and we know we're not building all these intersecting hyperplanes to figure out, data distributions. And so there's got to be a better way to do this. And I think people work on the problems they're incentivized to work on. And this power consumption and speed problem is only starting to become a big problem, right? The bigger problem has been the capabilities of these models and what could they do. And so I think you'll start seeing more people shift over to work on new ways of training. And I think that's part of what will lead to my earlier statement in the podcast about training and inference sort of merging and those lines blurring a little bit, where things you do or learn at inference time will be easy to work back into what you've done at training time, or continually grow and train models. I mean, reinforcement learning, which was really popular, say from 2015 to 2020, sort of fell out of favor. And I think it's coming back now. So
absolutely. And correction, it was 100,000 GPUs at the Stargate project alone.
Was it?
A million by the end of the year for OpenAI, scaling to 100 million. So that's going to be massive. But it's exciting to see inference time compute go from computer science, and frontier tech to being read about by the mainstream. And just a few months we've been at this. And so that's a big change. Exciting time. So that's it for today. Please like or subscribe. Stay tuned for upcoming product updates. Thanks for listening to Inference Time Tactics.